Good morning, students. Let us look into the topic called multiplexer. Multiplexer is a device which is multiple inputs and single output. That is the reason multiplexer is called as many to one device. That is many inputs and one output. It is also called as MUX. The short name for multiplexer is MUX. So the job or objective of multiplexer is it has multiple inputs, and the job of multiplexer is it needs to select one input out of several inputs and forward that one input to the output. So multiplexer's job is to select one input out of several inputs and forward that to the output. So how it does that selection process? It does that selection process with help of select lines. Okay, these two lines are called as select lines. This is the definition of multiplexer. So multiplexer is a device which selects one out of several inputs. There would be several inputs. The job of multiplexer is used to select one out of several inputs and forward that selected input to the output. So this selection is done with help of select lines. So this is a typical block diagram for a multiplexer where you have multiple inputs, single output. With help of the select lines, we select one input that will be forwarded to the output. You can see there are four devices connected to multiplexer through lines D0, D1, D2 and D3. You can see surround system here, surround sound system here. There are four devices: MP3, laptop sound card, digital satellite and digital cable. With help of these select lines, any one of the input is selected and forwarded to the output, so that that particular device will output is given to the surround system. This is the job of multiplexer. Let us design a 4x1 multiplexer now. So to design a 4x1 multiplexer, first we need to write the problem definition. The problem definition is to design a 4x1 multiplexer. The block diagram of 4x1 multiplexer is there would be 4 inputs and single output. Inside this block, you need to write MUX. MUX is the short form of multiplexer. What type of multiplexer I am going to design? 4x1 multiplexer. You know, for a multiplexer, there is a need for select lines to select any one of the input and forward that input to the output. So formula for identifying number of select lines is given by number of select lines is equal to 2 to the power of m is equal to n. Whereas m is number of select lines, n is number of inputs. For 4x1 multiplexer, how many inputs you have? 1, 2, 3, 4. So 2 by m, 2 to the power m is equal to 4 inputs. So 2 to the power of 2 will make what? 4. So 2 power 2 is equal to 2 power 2. Then value of m. Can you see here? Value of m will be equal to 2. 2 power m is equal to 4. So 2 to the power of 2. Whereas m value will be equal to 2. So I know the number of select lines is m. So there are 2 select lines now, S0 and S1. So for a 4 input multiplexer, 2 select lines need to be required. This is identified with help of formula 2 power m is equal to n, where n is number of inputs. If number of inputs are 4, 2 power 2 will make 4. So m value will be equal to 2. So S0 and S1 are the select lines. Now let us draw the truth table. See the truth table here. There are 2 inputs, S0 and S1. S0 and S1. How many? So now I need to, since there are 2 inputs, if select lines, how many combinations? 0, 0, 0, 1, 1, 0 and 1, 1. If S0 and S1 are 0, 0, I0 will be selected and it will be forwarded to output Y. So Y will be I0. If S0 and S1 are 0, 1, I1 will be selected and it will be forwarded to the output Y. If S0 and S1 are 1, 0, I2 will be selected and forwarded to Y. If it is 1, 1, I3 will be selected and forwarded to Y. So it is I0, I1, I2 and I3. Let us write the logic expression. You know 0 is S0, 1 is S0 bar. Okay. Sorry, you know 0 is S0 bar, 1 is S0. This is how you represent. 0 is a inverted term, 1 is true term, S naught. Let us write the equation for y. Y is equal to, when I get I naught, S naught bar, S1 bar, I naught plus S naught bar, S1 I1 plus S1, S naught, S1 bar, I2 plus S naught, S1, I3. This will form my equation y. Always you need to write 0 as S naught bar, 1 as S naught. Here 0 as S1 bar and 1 as S1. Clear? So this is how I got the expression y. From this expression I need to draw the logic diagram. This is the logic diagram. What is the expression? Y is equal to S naught bar, S1 bar, I naught. How many AND terms? 1, 2, 3, 4. So you have 4 AND terms. How many OR terms? All the 4 AND terms are connected by OR gate. So there is 1 4 by 1 OR gate. So S0 and S1 are 2 selection lines. True. They are complemented using inverter gate. So output of this is S0 bar, output of this is S1 bar, and the 4 inputs I0, I1, I2, I3. My first term is S0 bar, S1 bar, I0. So S0 bar, S0 bar, S1 bar and I0. I connect to an AND gate. Next one is S0 bar, S1, I1. S0 bar, S1, I1. I connect it to the next gate. Similarly, I do for third AND gate and fourth AND gate, and then connect all the 4 terms, product terms, to an OR gate so that I get my output y, which will be equal to the S0 bar S1 bar I0 plus S0 bar S1 I1 plus S0 bar I2 and S0 S1 I3. This is how you design a 4 by 1 multiplexer. Thank you.